We're asked to identify domain and range from a set of ordered pairs. Well, this one actually just says find the domain. The domain of a function is the input of the function. It's what's going into the equation or into the function notation. In other words, it's usually the x. So with ordered pairs, -5 represents an element of the domain. 8 is an element of the domain. 1 is an element, and 11 is an element because those are the x coordinates. And then they ask for the range. You can probably guess the range represents the y coordinates. Don't need to repeat them. So if like -9 came up twice, you just write it once. Okay, determine whether the relation represents a function. With a function, one input has to match with one output. Like for example, if you plug in x equals 1 and you get out x equals 9, you shouldn't be able to find another place where it says x equals 1 and x equals 7, right? It should always be x equals 1 yields y equals 9. Oh, I think I said x twice. Let me say that again. For a function, if x equals 1 and y equals 9, you shouldn't be able to get a different result somewhere. You shouldn't be able to get plugging in x equals 1 and then get y equals 7 or something else. Okay, so like this is not a function. You input a -1, get out -1. Great. But you input -1, you get out a 3. That's -1 has two different outputs. That's not a function. Input a 0, get a 6. Input a 0, get out a 7. Not a function. You can only have one output for every input. 7, you get a 3. -4, you get a 10. -1, you get a 7. Oh, that's not a function because two different inputs for the same type, two different outputs for the same type of input. Put a 1, you get a -1. 5, you get 12. -5, you get 9. 0, that one works. Every input has one output. 7, 5, -2, 0. Those all have their own unique outputs. So we're good there. Yeah, hold on, buddy. Enter a value to make this that would not make the relation a function. Okay, so yeah, for this you could put in -4 for the question mark, 9 for the question mark, or -5 for the question mark. I'll just do -4. Because if you put in -4, then -4 has two different outputs. It has 0 as an output and 8 as an output. So one thing you do with a graph is you can check to see if every input has one output by doing something called the vertical line test. Imagine a vertical line going through every point in this graph. If it touches in two places, it's not a function because that's two outputs for one input. But every vertical line I imagine here only touches one spot, okay? So that's a function. Every vertical line touches one spot, so that's a function. If I imagine vertical lines, this is a function too. Now here, if I draw a vertical line right down the center here, I cross this up here and down here. So there's two outputs for my one input. I think that might be everything. Let me see. Oh, we've got to determine if the relation is a function. So 1 second. Okay, determine if this represents a function. Means every input of x, I should get out one for just one type of output for y. If x is the function. So what you should do with these is you should solve or simplify them at least. Try to get y by itself, because y is going to be our output. Oh. So let's solve for y. Let's add 9x to both sides. We're left with -3y squared equals 6 plus 9x. Then we're trying to get y by itself, so divide everything by -3. So get y squared equals -2 subtracted by 3x. And then in order to get, well, I guess we can kind of stop here. Look, if x were to equal -1, -1 times -3 makes 3. 3 plus, it's a positive 3 plus -2 would make 1, right? And I picked that number not out of thin air, but I was quickly imagining how could I make this equal 1 just so we could have something to easily look at. Look, if you put in x equals -1, there's two different numbers you could get out for y. It's perfectly fine to have y equal -1 because of the squaring. Okay, so anytime you get something like this where y is being squared, it's not a function because you can get two different outputs for the same input. So this is not a function of x. Other thing you could do is you could graph this. There's y squared again. We're going to go to it not being a function of x. But you can graph it in Desmos and do the vertical line test like we just saw.